Hello, hello, hello.
Hey, how's it going?
Hey, how?
All right, how are you both today?
Doing pretty good.
I'm fine.
Excited to be joining. I guess this is my sort of second time on the stream. I don't know if the first one counts. It wasn't official. It was impromptu. So, but we
Are
can
those
kind
the best streams though, right? The impromptu ones where you have no idea what's going on are kind of, I
of
mean,
right.
this is my 20th time and I still have no idea how to introduce this stream other than be like, hi. Like
Yeah.
eventually I'll come up with some sort of script, but for now, winging it is working all right.
Yeah. Well, I will
Uh,
say you've been getting these streams out super fast. 'Cause when did you start doing this specific show? Because I've been watching and it's like it's almost like daily at this point. Whereas I think I've been doing streams for about a year now, and I'm at like 21 shows. So like your pace is infinitely faster than mine.
yeah, I'm averaging 3 a week right now,
Wow.
which is quite a lot. And but I mean, as you two have just found out today, there's like zero prep. I pretty much just find people that are doing cool shit and like say, hey, do you want to come and join me? And then just, free flow kind of go through the technology and see what works and what doesn't. Like it's not like there's a whole lot of prep going into this that's taken loads of time. So,
Fair
uh,
enough.
not that I should be broadcasting to other people that are going to tune in and watch, but like, this is really polished and we all know exactly what we're doing.
We've
Generally.
rehearsed for weeks.
Okay. So today's mission is we're going to talk about some Kubernetes cool stuff. I believe, and you can correct me if I'm wrong here, but this is mostly possible since Kubernetes 1.19, which came out last week. Is that correct?
Oh, we are backwards compatible. So we are always
Oh.
trying to bring up some enhancement to the community, which works on previous versions of Kubernetes too. So
Okay.
yeah, but the initial reason for our work was that we found out during the graduation of Seccomp to GA in 1.19 that, hey, there are so many enhancements which could probably go with that feature, but it probably would be better to put them out of the tree. And now we have our little community around it, and we are getting more and more contributors to the project. And yeah, we're pretty happy that we can provide some valuable content to the community in that way.
Yeah, I'm really excited to play with this today, actually. It's one of those things that I know, security is a big deal, especially when we're talking about cloud computing and Kubernetes, and especially if you've got public-facing traffic of any kind. So reducing attack vectors and all that other stuff. I'm not going to pretend I know about security, but I know a few words I can drop in, like attack vector. And Seccomp Operator, which is a project that you two have been involved in, I think is a big component of that. So do you want to just take a minute to describe what this project is and how it works and helps people be secure in Kubernetes land?
Dan, do you want to take it?
Sure. Yeah, I can jump in on that. So as Sascha said, Seccomp has existed in Kubernetes for quite a while, and in the Linux kernel as well. So basically, Seccomp is just when you have a process running in user space, it typically to do anything meaningful needs to access some of the functionality in kernel space, and to do that, it uses syscalls, right? So it says, "Hi, kernel, like you have more privilege than me. Please go do this task for me." And so you can imagine, since it has to communicate in this language, you could pretty easily put in a layer there to filter what calls are going through to the kernel. And that's a pretty effective way to establish security boundaries on things, because the functionality of different syscalls is pretty well defined, though there are a lot of them, which we'll probably find out later on in the stream. But being able to restrict what syscalls a process can accomplish is really effective, and especially when you bring in containerization, you can apply profiles to that. It can get a lot more effective. So anyway, you've been able to do this for quite a while with annotations on pods and containers in Kubernetes. And you can also do that on pod security policies to enforce these sorts of things. Most container runtimes, which for folks who aren't as familiar with Kubernetes, Kubernetes is an orchestration layer that sits on top of a container runtime, right? So you could swap out the underlying container runtime, which we may talk about a little bit, but most of them ship with kind of a default Seccomp profile, which is like, this is the bare minimum security you could have here. It's like, it's not going to do anything too atrocious. But most people, you won't even see enabling that, right? Because it is an annotation you have to add. So it's kind of like unstructured data. It's not a formal field if you look at the API spec for a pod. So yeah, you don't see it used a lot in Kubernetes, even though it's been around for quite a while. And as Sascha mentioned, as part of the 1.19 release, Sascha and I and Paulo Gomez, who led a big part of this as well, graduated Seccomp to GA. So essentially what that means, and this sounds kind of simple, but if you're familiar with kind of how API changes work in Kubernetes, you'll know it's not super simple. We basically just took those annotations and made them a formal part of the security context. So that has a number of benefits. One of the biggest I see is that it's just a field that's there in the API spec, right, that you can set as part of your security context. It's in the documentation as such, and it's less of kind of like an afterthought. So anyway, basically same functionality for the most part, but just moving that to the actual formal pod spec. And as Sascha mentioned, as part of that, we wanted to enable you to make it easier to use Seccomp. So once again, for folks who aren't as familiar with Kubernetes, typically there are a number of nodes running. So each of those nodes have a container runtime on them. The Kubernetes scheduler is going to go and take your pods, which are made up of containers, put those on the nodes, which are going to run those with the container runtime that they're interfacing with. So you can imagine if Seccomp is something that's at the kernel layer, that is on a per node basis, right? So you can't just say, I'd like this Seccomp profile to be used and assume that it's present on all nodes. Right now, you have to actually go in and, when you're setting up your machine or SSHing into your machine or something like that, you have to go and actually put them in a directory that's specified with the kubelet flag, and make sure those are present on all of your nodes. So it's very, for something that you can configure on a pod spec, it's very divorced from the actual running of a workload, right? It's very much a cluster administrator activity, which, has some pros and cons, right? Typically the cluster administrator is going to be knowledgeable of those things and can do it. But if you want to, constantly be changing the Seccomp profiles that are available and creating new ones for different processes you're running in a different container, then that's kind of a pain, right? So let's say I'm running a workload and I'm just a developer in my organization. I need to create my pod. I don't want to have to email my cluster administrator and say, hey, will you go make sure there's a Seccomp profile on this node? And then I'm going to put, like specific node taints on here to make sure the pod gets scheduled there and do all of that. Like it's mixing of responsibility there. And it's kind of like moving away from this whole pattern that Kubernetes is trying to enforce. So what we'd like to do is take the Seccomp functionality and make it available more at that developer level, or just make it easier for cluster administrators to use and create pod security policies. So anyway, the Seccomp operator is kind of typical to Kubernetes operators. It watches an API type. Right now, we're just using config map, so there's no new API type that's added. And that config map has data in it, which is basically just Seccomp profiles, and it'll go and it runs as a daemon set. So this operator is running on every node, and it actually goes and puts those in the correct directory, which means that you can then say on your pod, use this Seccomp profile with this name, which I know exists because I can kube control get my config maps that are Seccomp profiles, and know which ones are available to me, and then apply them to my workloads. And we can run through doing all of this, but that's kind of the main idea. We'd like to make it really easy to use this really valuable functionality.
Okay, there is a whole lot of information there. So what I'm going to do is make sure that I've understood it correctly, and I'm going to try and scribe it back to you now.
Sounds good.
So Seccomp, right? Let's remove Kubernetes and containers for now. Is a Linux kernel primitive that allows me to define the syscalls that any binary running on that machine are allowed to execute. Right?
Exactly.
The Seccomp profile is something that I have to craft myself, and I put in a directory that the Linux kernel expects it to live in. And so how do you connect the profile to the binary? Like without Kubernetes, like if I was just doing this on a Linux machine, how would that work?
Yeah, I mean, it's more or less So the profiles itself are not written in JSON. So they are just, for example, you can use libseccomp, which is a C library, and then you can use it to interface with the Seccomp BPF filter, and then you can generate or build the filter. For example, you allow only a subset of syscalls for your currently running architecture. And then you have to call something like filter load, and then the filter gets loaded into the kernel and attached to a process. And yeah, that's it. So it has to be attached to a running process.
Oh, okay. Okay, that was a bit of a disconnect for me then. So I have a running process, I attach the profile to it, and that process is then secure. If that exits and is rerun by someone else, I would have to reattach the profile?
No, I think the profile is gone if the process exits. But I think originally Seccomp had no BPF support, so there was no support for those data structure where you can specify different syscalls. In the first place, it was just something like, okay, we want to use Seccomp or we don't want to use it. And if we enable Seccomp for a process, then the process can't do new syscalls. So that was the main intention, but that wasn't flexible enough. And then they decided to go for BPF. It's not eBPF, so it's not this extended BPF filtering, but it's just a plain BPF. So there's more or less something like you can imagine it something like a lightweight kernel module which gets loaded on runtime and then traces and blocks the syscalls. So we have different actions, right? So we can block the syscalls, but we can also trace them or lock them. This is possible as well.
Okay. Now, from my naive perspective, is it okay to think of Seccomp as like a firewall for syscalls?
Yeah, probably. Yeah.
Okay, the next stage there that Daniel went over was that Kubernetes has support for the Seccomp profiles, and they're handled through annotations on the pod spec. And the challenge with that is that they don't always exist on all the nodes. Is that correct?
Yeah, so there's a couple challenges. Like the first one there is that it's, annotations are like an unstructured bag of data, right? So it's not immediately clear. You're not going to get like validation on your annotations like you would with, the open API schema of a pod. So that's kind of the first thing. But more in relation to what you were saying. So when you create a pod with this annotation, let's say it's pre 1.19 before it's moved to the actual security context. If that pod gets scheduled to a node that didn't have that Seccomp profile, then that would be an issue, right? Because it couldn't apply it. So you could say, typically, well, actually, I guess it depends on the organization, but typically you'd either have them on all nodes in your cluster, or you'd have a very specific workload. Maybe this is even more likely because Seccomp isn't super common to have enabled on workloads. You typically have, a specific node that you're like forcing scheduling to that has these Seccomp profiles there. So yeah, basically, the pod is an abstraction for scheduling, but Seccomp doesn't really like fit into that abstraction, unfortunately, right? It's node specific. And you see other things like, let's say you want to use like GPUs or something like that, that's on a specific node. There's other times you have to do this, but because this is built into the container runtime, you basically shouldn't have to do that, right? It's not like specific hardware. It needs to be, like obviously like a Linux node and that sort of thing. But we're kind of paying a price right now that you shouldn't have to, at least in our opinion, I think.
Okay. I'm kind of following along. I think the best way to tackle this is let's play with it. Right?
Yeah. We also have this kind of hierarchy when it comes to annotations or passing data around with annotations, right? So this is, from my perspective, kind of a little of a problem for making users actually use the feature, because they have to specify an exact annotation. And then they can say, okay, now this profile applies to the pod, but they can also say, okay, it's /container name, and then you can reference your container name inside of the pod to apply the Seccomp profile only to a single container. So and this fact already makes it pretty complicated to use. And yeah, we can solve that issue by having a dedicated field in the security context of the container and the pod.
Yeah, if we jump over to the repo, we could look at some examples. I think we have some of the pods with annotations and with the security context probably be helpful to take a look there.
The Seccomp Operator repository, right?
Yep, in Kubernetes SIGs org.
Yeah.
I think Sascha already put a link in here too.
There we go.
Nice. All
Yeah,
right.
you can ignore this mind map right now. It's just our brain dump.
I'm not sure I want to ignore it.
It's very
Okay.
colorful.
Later. Okay, so what do you want me to pop open then?
I think installation and usage might be good. Yeah,
Installation.
there at the top.
That would make sense. Yeah, definitely.
All right, so yeah, we have our stream there, and then here first it's looking at installing the operator itself, and then it's looking at creating a profile. So we talked about beforehand that right now you'd go and actually kind of like put these JSON files in a specific path on your node. And so what we're showing here basically is just putting those JSON files in a config map. And what the operator is going to do is it's going to see that because of the annotation there that's seccomp.security.kubernetes.io /profile. So it's going to say, the operator is saying, look at all config maps with this annotation on it. And then it's going to take all of those profiles in line there and just put them in a directory on all of your nodes, right? So it's a daemon set. This operator is running on every node. So each one of those processes will go and actually put that on the node. And if you scroll down, then we'll show usage of it, which this usage obviously is not specific to just Seccomp Operator. You could manually put these in there and then do it, but you'll see the top one here is with 1.19 where we have the security context there and Seccomp profiles and actual field there. And then you'll see before 1.19 below that, you have that annotation, which is a little more cumbersome, right? You're not going to get that validation and that sort of thing. So yeah, that's the general idea. And as Sascha also mentioned, a security context, you can have it at the pod level, and then you can also have it more granularly at the container level. Just like any other thing in the security context, the container level, the more granular one is going to override the top one. But if you're doing that with the annotations here, they're like at the same level but overriding each other, so it can be a little bit confusing as well. Here they're both being applied at the pod level though.
All right, got it. So I guess I could just run through these steps on my cluster, right?
Yeah, sounds
it's going to be nice and easy. It's going to work, and then that's it. So I am running on a Mac, and I still don't know how to open tabs. There we go. So that means that I have a server version of 1.16. So if I'm working with the Docker for Mac Kubernetes, that means I need to use the annotation-based approach, right?
Yes, you would need to if you're using 1.16 Kubernetes.
Perfect. Well, let's install this operator. And I appreciate that it's a kubectl apply, not a create. And this is going to put stuff, I'm assuming, in my kube system namespace.
No, we use it
Seccomp Operator.
Yeah, exactly.
Yeah, and so you'll just see one pod running here, right? Because it's a single node cluster you have here, presumably. So it's a daemon set, so just one will be running here. One thing you could also do is well, I guess you can see it right there, the other things that were created. So you can see that we have a config map, which is for the Seccomp operator itself. So, as you would want with something that is going to manage your Seccomp for you, we apply Seccomp to it as well. So that's what that config map is for. Then you'll also see the default profiles there, which is just a collection of profiles that would be, we think, universally useful, especially right now when people are just kind of like getting their feet wet with Seccomp. There's some things to try out. So yeah.
All right. So I guess I could just pop this open and take a look at it, right?
Yeah, go for it.
And you're going to be able to tell me what is actually going on here.
Yeah, we're going to
So this
describe
is-
every syscall to you and exactly what happens in the kernel.
Well, here's a random pop quiz for you. How many syscalls are there?
What is it? 200?
Two-
Is there 300 yet?
I don't think so.
There's 200 something.
Yeah.
200 something. Okay. So very meta then. The Seccomp operator ships with its own Seccomp profile.
Right. Yeah. And Sascha, I mean, you or I could go through how we actually there is some like the init container, I think, is kind of interesting how this gets applied. So we might want to look at actually, there's kind of like a chicken and egg thing, right? Are you using how can the Seccomp operator like do the things it needs to do with the Seccomp profile if it doesn't exist yet to put the Seccomp profile there? Like there's a chicken egg thing we can go through in a little bit. But Sascha, do you want to give kind of like a rundown of what this profile has here, just like the different sections of the JSON here?
Yeah, first of all, we have our default action. So we just want to throw an arrow in any case if any of the syscalls which are allowed. So this is the list down there. Any other syscalls should be forbidden. And then we have our architecture. So we don't have support for something like MIPS or S390 or something like this. So we just support x68 architectures for now. And then you have a list of syscalls which are allowed. And if you go a little bit more down, can you go down to the list? And there should be also an action related to those syscalls. Yes, so it's the action allow. And those syscalls are allowed. We could also do it the other way around, right? So we could allow all syscalls and deny some of them. But yeah, if there's a new syscall coming into a system, then we probably would allow it. So it's not the intention, not the right security approach from our perspective here. Yeah, now we have a little list of syscalls, and some of them are necessary to actually spawn the process. For example, if you look at execve, if we wouldn't be allowed to run execve, then we wouldn't be allowed to actually spawn any process. So runc or the underlying container runtime wouldn't be allowed to actually execute the workload process. So this is something we have to really keep in mind. And there's also something like uname down below, probably. It's just a rough guess. Yeah, there's uname. And this is something which is required, for example, for the Go runtime. So we wrote a Go application, and when we start this Go application, then it does something like a uname to look up some resources on which system we are running on and stuff like that. So the runtime has a little garbage collector running in the background, and it's necessary to run the uname. If we, for example, would deploy something like a C binary, which is statically linked, then we probably would not need uname at all, or we wouldn't need syscalls like read or something like this. And it wasn't that easy to craft the profile, but we kind of recorded the syscalls, and even after recording the syscalls, we just saw that, okay, there are some syscalls missing, and this also kind of influences how we develop the application, right? So if we want to add now new features which need new syscalls, then we indirectly have to adapt the Seccomp profile as well. And this can be kind of pain, but yeah, I mean, it's really a security-driven development approach, and I really appreciate that.
Yeah. So, Sascha, I think you pointed out something really important there about some of these syscalls are like kind of unrelated to the actual process that's eventually getting run, right? Some of them are specific to it running in a container runtime, et cetera, which I think really emphasizes something we were talking about before we started this stream about wanting to be able to record the profiles using the Seccomp operator. Because if you were just, looking at this binary by itself, depending on, how you are running it on your machine, you may not need all of these different calls here, or you may need some that aren't present here, et cetera. So, developing one for the specific context you're running in can be a bit challenging, which also gets introduced, right? If you want to, for instance, I work on another open source project for like my day job, and we did a stream a while back of crafting a Seccomp profile for it. It's a little bit difficult to kind of like ship a Seccomp profile with your thing that's going to be like generic, right? Because you don't know the context that people are going to be running your application in. You don't know the underlying container runtime. You don't know a variety of different things. You don't even know if they're running it in Kubernetes, perhaps. So shipping a Seccomp profile alongside of it is difficult. But we think that just as, you install, let's say, like a service mesh that has like security context on some of the pods that are running, we think you should be able to ship a Seccomp profile with that, and that should be able to work. And if for some reason it just absolutely cannot, then we should have an easy out for that, right? So that's another area where we'd like to make this a more seamless process.
Okay, right. It's starting to click. I'm getting there. So I think the first question I kind of got is, we've just deployed this operator now. What is the process when I get this wrong? Like, say I go and run a container here, a pod here, which has a profile and is trying to execute a syscall that doesn't exist. What kind of errors, what logs am I getting back? Is there something to help me understand what's going on?
Yeah, so the first thing during development of such a profile could be to put the action not to error, but to its section. It's a Seccomp action log, right? Mm-hmm. Which logs the error messages into the audit log. And the audit log is something, so it's audit D, and audit D is not available on every system, we have to admit, and it's also configured differently on systems. But for many default distributions like Ubuntu, for example, then that would result in logging the action. And this is call number. You have to look up this is call name, then if you just get a number. All
right, I've got an idea. So before I go through my weird idea, let's pop open that other config map, right? So we got the default one. So the idea behind this default one then, and I'll just put words in your mouth and you can correct me, is that this should allow most processes to run without, I guess it's blocking the more extreme or dangerous syscalls. Is that what it does?
I mean, this profile, we wanted to provide some default profiles for some common applications. And for example, this is for nginx, I think so. We only have one for nginx right now. And
okay. I think I misunderstood that. I thought this was like a default profile that would like just block really dangerous syscalls and let everything else through.
Oh, no. Most container runtimes already ship their default profile, but on the other hand, we have to say that the default profile in Kubernetes is unconfined, so it's not applying Seccomp at all. But it's the profile called runtime/default, or the deprecated profile docker/default.
Yeah, that's a really good point. So like right now, without the Seccomp operator at all, you can use the underlying container runtime default profile, which does exactly what you were talking about, David, that it blocks super dangerous things. Honestly, like that is enhanced security. It doesn't really go a super long way for preventing things, because right, it doesn't want to break your functionality, right? But that is definitely the first step. I'm glad you pointed out. That's definitely the first step to using Seccomp. Just using the runtime default profile, and if you're seeing issues, then you probably have a fairly privileged workload that you're trying to run there. All
right, I'm curious. What happens if I don't allow the exits this call?
It depends. It depends on the application, right? So this is another good point. So when recording syscalls, it's not like when you start a process that it just makes like every syscall ever. Especially if it's a long running process, like an operator. So the Seccomp operator is a great example of this. Depending on input it receives, it might make different syscalls. So you can't just like execute it and be like, all right, I know everything that's running. You technically should have to go through like every path to be like totally sure to know, not literally every path, but basically the idea is that you need to have some real world use of it to be able to understand what calls it would make, which is a great case for recording, right? Because you can just monitor something in its normal operations and see what happens there.
All right, awesome. I'm feeling brave now.
But for example, exit is pretty interesting because it would mean that the process is not allowed to terminate itself.
So that's what I was wondering. What if it wants
yeah,
to
and
exit? What if it's finished?
yeah, and this could result in that the process just hangs around. I mean,
wouldn't if it tried to make a well, it depends. I guess it depends on what your policy is. But if it's an error policy, I believe that the process is going to get killed. So maybe you're like effectively exiting there anyway. Like maybe we should just remove the exit call from all Seccomp profiles and then just have it killed when it makes it. But that's a funny one to look at for sure.
Yeah. So if the default action is to audit and an application wants to exit, it's just going to live forever.
No, it would be if the default action was to audit, it would log that an exit call was made and allow it to actually exit. So it's not, it doesn't prohibit it from happening.
Okay, cool. There we go. Let's deploy nginx then. Is that the next step here?
Yeah.
All right. Works. So if I just do this the really hacky way and then we edit it, we can add the profile. Or is there something on the documentation here that's going to make this? Okay, we'll do it this way. I'll follow the documentation. I'm a good citizen. So, nginx with Seccomp.
Oh, the namespace has to be changed. I think so. Also, the config map name.
Oh, so this is the 119 syntax actually. So what we're saying is I can't use that, and I need to use this one. So I can just copy these annotations. And so localhost, I'm assuming the stays operator is the operator. My namespace is going to be Seccomp Operator, and default profiles nginx.
It's nginx 119.1.
So if I wanted to get that, that's just the details from. If I just describe config map, there we go. Default. Oh, okay, because it's. I'm just trying to make sure that I know how that is built up. So this is the key here. The namespace of the default profiles is coming from the names. So that's localhost operator, namespace, config map name, and then the key within the config map.
Yeah. So the reason for that long path was to not being able to override the Seccomp profiles from a different namespace if I don't have access to it, and things like that. To have a security from as the pathing is the security pattern here.
Yeah, right. And you can also, as we'll see later on, you can run the operator itself in a single namespace, basically only watching for config maps in a namespace. So you could say like all of my config maps will always be in the Seccomp operator namespace, and I don't want people with access to other namespaces and the ability to create config maps to be able to do that. That could become less relevant, as one of the things we're exploring right now is creating a Seccomp CRD, where you have a specific type that you could grant RBAC on. So there's kind of like a trade-off, right? Because using a config map is something people are already familiar with and know how to structure. But you have unstructured data in there now, right? It's just like a bag of JSON that's not getting validated on creation. And you can't apply RBAC specifically for, you could use OPA or something to write policies, but you couldn't apply RBAC to say like, you can't create Seccomp config maps, right? You can only say you can't create config maps or something like that, which obviously those are used for many different things. So you may not want to do that.
Is there a plan to introduce a CRD in future versions?
Yeah, there's actually a PR open right now, which I definitely want to give the person a shout out. So, Sascha, I didn't remember their name. If you wanted to drop
Colleen.
Yeah, Colleen. So she's been working on that, and there's a PR open on the repo if folks want to kind of like weigh in on that. It's a fairly straightforward implementation, right? Because there's already a defined like API for a Seccomp profile. So it's kind of just like adding that in. But there are a couple of like decisions about how we want that structured, if you wanted to be able to put multiple in one CRD or, et cetera. So definitely people are welcome to weigh in on that.
Awesome. I'm looking forward to playing with that too. So what was I doing? We were going to apply this into the next podcast. There we go. That's my problem with these streams, is that I just have too many random thoughts in my head and I just digress far too much from what I'm actually supposed to be doing.
Yeah.
That's how you end up talking about interesting stuff, though, right?
I hope so. I certainly find that interesting, that's for sure. So,
It's definitely more fun for the people on the stream.
cool. I'm glad. So we have a test pod now that is running with the nginx profile based on the annotation. Let's just
Nice.
let me just check then, right? So I can do a port forward to our test pod and just confirm that I actually have nginx. Like that's to me that's step one here. So
Nice.
now
We
I'm
are
going to go
software
inside of
engineers.
this pod. I do wrong.
Let's see here.
Oh, this syscall failed. Is that what that is?
Potentially, yeah.
Yeah. I mean,
So I was going to exec into it to do something
Yeah.
nginx wouldn't do, and already it's blocked me. So.
Yeah, that's a good example right there. I mean, like, you want to restrict your images with things it doesn't need, like, you don't want someone to be able to exec into it if they don't need to. But here, that adds another layer. Let's say you want to use the nginx pod and you don't want people to exec into it. Apparently, your Seccomp profile will disallow you from doing that here.
So what I'm going to do is go add that syscall and just assume I know how to do it. Please, if I get anything wrong, yell at me. We do have a question if you're feeling brave as well. So I'll pop that up just now while I do the edit on the config map.
Cool.
The
Yeah,
question is from.
Go ahead.
The question is from Robert, and he's saying, so could the operator log syscalls an app made that would prevent it from running by the profile?
Yeah. So if you set the default action or the action on a stanza to log instead of like error or allow, then it is gonna log those out. I think that we could make that a little bit easier to consume. Like there's ways to get to that log. Like for instance, in the example in the Kubernetes docs that we added, I'm running like a kind cluster locally. So I just literally tail the syslog on my local machine, and I can see those syscalls logged out there. But, we could potentially make that easier to consume or you could already export those somewhere else. And there's probably frequently people are. But building something into the operator that would do that would definitely be interesting as well. I don't think we want to shove too much into this operator, right? Like it shouldn't be like your logging mechanism, for instance, but if there's something around making that easier to consume, I definitely think so. One thing we could do is, do some sort of like eventing on a pod or something like that to say like, oh, this was killed for this reason, right? So it should already say if we got the pod now, like, something happened. It might actually even say that message there. But, if there's something we can add to that to make it a little more transparent, that'd be a great idea for sure.
Awesome. Really good answer. So while you were answering that question, I did edit our config map and I added that syscall, which is, now I can't even remember the name of it. There we go. Get pgrp. Which syscall is that? I'll ask you on the spot.
I have no idea. Sascha, save me.
Let's just see what
it's related to users and groups somehow, but I'm not exactly sure what it does, but it's something like user or group.
So
yeah, it looks like it's setting and getting process groups.
Yeah, so I got the group ID. So I've added that. Now, I already have a running pod. I'm assuming that won't be updated in real time. So will I have to kill the pod and redeploy?
Exactly. Yeah.
Okay. All right, so we can delete. Did I call it a test pod? Do that whole thing.
I expect another syscall now to show up, but let's see.
Me too. This is the joy of crafting the Seccomp profiles. And like I said in that tutorial, we do it by just logging all of them and then like adding them. Well, we also give you the completed one, so you don't have to do it. But when I was writing that, I was logging them all. And, it's like, oh, this one works now. All right, what's the next one we need to fix? So it can be confusing for sure.
Yeah. Well, I just did a grace period 0 and a force. It's now away. Let's just hope. Let's give that now. Okay, so
Good.
How many of these do you think we're going to hit before I actually get inside of this this container?
Oh, a few for sure.
There's no syscall logged here though. Oh, cannot set terminal process. All right, so let's assume we're already understanding why this is a bit painful now. We knew this was coming, so why don't? Because it could be dozens, right? There's no point in going through these one by one.
Yeah, I mean, like for this, there may be a point in doing it for your production workload, but you're right. There could be dozens, right? Because it's going to kill on the first one. You could also set it to log, right, and potentially get all of those at once. Seen. So
okay, that's a really good idea. So but I'm curious first. Can we set the default runtime one first? Can you tell me how to do that? Then we'll come back and maybe change the nginx one to do log instead of error. Does that make sense?
Yeah, sure. Sascha, do you want to instruct that one?
Don't we want to change? Oh, okay. I thought we would like to change to not to error but to log for the nginx profile, and then we could look into audit log. I'm not sure if audit D is configured on your system, but I would expect so. So we should already see some syscalls coming in from the workload.
So what I was curious was, what we're saying is if we don't want to use the default ones that are provided, there is the container runtime default. I was wondering if I could apply that to then exec into the container.
Then, yeah, this should work. Yeah, we can try it out.
Yeah, so I'm assuming the annotation is the same, right? So
yes.
Yeah. So
it's just runtime/default.
Is that it? That's all I need to get a default?
Yes. Yeah.
Why is that not in every piece of documentation for deploying pods ever?
Because it's an annotation. Maybe. Maybe because no one knows what Seccomp is who's using Kubernetes. I'm not sure. That's probably a huge generalization, but I know a lot of people are not familiar with it. But anyway.
But
sorry, Andy, go. Sure.
Yeah, the fun fact is that we're actually running a different application, right? So we're running on top of Bash now, not on top of nginx.
That's what I was really curious about. That's what I wanted to do with the default nginx profile. Is I didn't think I would get blocked from getting inside the container. That was just a value add. That was cool. What I wanted to do was something dangerous. Like the attack vector that Seccomp is helping people with is if someone penetrates my application and gets access to the container, we want to stop them doing things that this application isn't supposed to do. So now that I'm in here, like, is there a way for me to introspect that Seccomp profile? Is it available in a container under /proc/1? Like,
no, I don't think so. The underlying container runtime in our case probably runs C and applied the profile already, so it's not possible for the process at all to inspect the profile now because the process is not that privileged. We also, we don't have access to something like this. But what
would it block me from doing? Like, what would be a bad syscall?
I mean, runtime default is not very constrained, right? Let's just double check.
Yeah, I'm taking a look at it right now. Let's see.
Because I'm assuming, right, if I could run PS, I would only have seen one process anyway. I guess I would be able to. I can send syscalls to the kernel from here, right? Is that possible? Can I just send the syscall?
You could try. Let's see. Significant syscalls. Here, I'll drop this in the chat too.
Yeah, I'll open it up. Let's take a look. I'm curious.
Do we have something like ns-enter in the binary ns-enter, for example?
No, I'm assuming we can maybe get some tools though.
You could use like set and s or something like that.
It's probably Debian based or Ubuntu. Yes. Yes, ZNS or ns-enter should not work. This should be blocked probably, because it would allow modifying the namespace.
Oh, namespace. It's there. It's namespace.
No, is ns-enter in path already?
Priv. That sounds dangerous. Run a program with different privilege settings. I mean, that sounds like something I shouldn't be able to do within a default runtime.
I don't think it's actually explicitly blocked though, from what I'm looking at. So let's see. Does it have? Wait, let's look at the ones there.
I'll just look it up. I don't mind. So we're looking for set NS inside of Ubuntu. Well, likely Ubuntu or Debian. So,
ZNS is allowed per default, I think so. At least on my default profile I'm looking in. I'm looking at a different profile.
So right now, as an attacker, I'm in quite a good position then, even with the default, potentially in a good position with the default runtime.
Yeah, it depends on what you're trying to do, but like we're saying, it's pretty permissive.
Okay, right, we'll move on. I'm not sure what I can do here to try and trigger that default Seccomp profile to fail. Can we see that profile?
I'm looking. The one I just put in the chat here looks like the one for Docker. So this has a list of all the blocked ones. I don't know if like clone may be available.
And it's also part of the allowed syscalls.
It is part of the allowed ones?
Yeah. Oh, it says block on the Docker docs, yeah.
All right, it's interesting.
It also says I can't mount. So in theory, if I were just to like do a loop back mount, if I can even remember the syntax for that.
Yeah, you can just, something like this should work.
Overlay, upper, I'm never going to remember that. Overlay, there it is.
Which profile were you looking at, Sascha?
I'm looking into a containers common profile, which is used by Podman and Cryo, but it was originally adopted from Docker. Let me just, I have a JSON here. Just link this one.
Nice.
Okay, so that worked.
Yes.
Is that the syscall blocking me there, I'm assuming?
That's just the permission levels of the user, right? So it's not actually even getting to making this syscall there, I don't think. Is that how you interpret that, Sascha?
But if you just leave those arguments away and just do something like mount 1 to 2 or something like this, should probably also not work. 1, 2. Yes, it's blocking. It looks like that this is blocking.
Okay, so we can test that, right, by just deleting our wonderful pod here, removing that one line, and then see if I can execute that command.
Yeah.
I don't know what I'm trying to show to myself here. I'm just I'm just now curious.
But you have to remove the workload, right?
So 1, 2, 1.
Yeah.
I think that's the same error.
All right.
Oh well, there goes that plan. So what we're going to do now is we are going to change the nginx profile to not give me the error, and then that should allow me to exec in, and then we can understand the default action stuff. So I pop open this default profiles again. And the default action is this, right?
Mm-hmm. So if you just change error no to log, then when you encounter something you're not allowed to do, it'll just log it instead of killing the process.
Just close that. Okay, and then I can delete and reapply. If I run get pods, haha, what have I broken?
Yeah, describe the pod and see what the events look like there.
Error create and filter. So is my profile?
Yeah, I'm wondering, does your
wrong?
profile exist?
I'm assuming this was the problem. What do we have down here? So yeah, this is our explicit allow, our default action. So where would I find the default actions if I wanted to see what options I have available here?
I believe the only actions are log, error, no, and allow. I'm fairly certain. Let me make sure on that though.
Yeah, those are the actions which are part of the runtime spec, the OCI runtime spec.
I always break stuff.
Yeah, that's interesting. So did you apply the updated profile before you created this pod?
Yeah, well, yeah, I'm editing it in line. How does the operator handle changes to the config map? Do I need to restart the operator?
You shouldn't need to. See if there. Will you describe the config map? Because we do event on the config map, so you should be able to see if anything went wrong there. Let's see. So 3 minutes ago, that would suggest that that was saved successfully. Interesting.
Why don't I edit it again?
Yeah, and then also look at that pod spec and make sure that it's the right name.
Error no, we said was allowed. If I describe again, that's now 4 minutes without a saved Seccomp profile. What does that mean? Is it not picking up the changes? Is this a weird Docker for Mac thing we're going to find? And it's
Yeah, try and
we just remove. Oh no.
Yeah, try and removing the profile, and then let's see if we can add it again. Or you can just delete the config map either way.
Yeah, let's delete the config map rather than doing that. So delete Seccomp config map.
Do you have a copy of it locally?
I just copied it, yeah.
Okay,
So
nice.
you can have default profiles, YAML, and I'll remove all this generated crap. There's one I need there.
Yeah, make
Do I
sure to
need
keep
the
that
app label?
profile true. You shouldn't need the label, but you do need that annotation there. But yeah, if you leave it, it probably won't hurt.
Yeah. Okay, so we've got this. And our profile, that was good to me. Let's change this back to the log web.
Okay.
And we'll apply our default profiles.
Nice.
So let's redescribe. 4 seconds, okay.
Cool.
So now that we've got this as log, what we're saying is we can now redeploy our nginx pod, and I may or may not be able to exec into that. That log definitely seems to be.
Yeah, that's interesting. Oh. Let's see. Error creating. That's interesting. I haven't seen this.
Can we?
Should we just ditch Docker for Mac? Is that when we move over to a straight up Linux box? Maybe that's going to be a bit easier.
We could give that a try. Yeah,
I'm just
not
curious
sure
if
why.
Docker for Mac maybe doesn't implement the default action. I mean, is that possible? You're saying it's an OCI spec thing, so it really shouldn't be, right?
Yeah, it shouldn't be an issue to change it from error node to log, but yeah, we could try it on your Linux box if you want.
There was something that Sascha said earlier where it logs to audit D. Is that what?
Yeah.
But now, what if that doesn't exist? Because this is going to be a Linux kit VM. Like, I'm not sure if things like audit D would be there.
I think it should still work. I don't know. Correct me if I'm wrong, Sascha.
I'm
not
just
sure.
swinging
I'm not completely sure about included bits into the logging mechanism. I know it logs to warlog messages and it can also log to audit D, but I'm not sure. Interesting.
Okay.
Yeah, let's try it on the Linux box and see what happens.
Yeah.
All right. So if we close this one, this is my Linux VM. So I came prepared because I figured there might be something that happened with Docker for Mac. Although I'm not that prepared because I didn't install Kind. So I don't think that's going to be available there. Is the Minikube? Otherwise, I'll just grab it. Yeah, okay, let's just get the Kind off. We also have a question, so why don't I leave that to you two while I do this? So Bala is asking, maybe a silly question. There's no such thing. There's safe space here. Can this operator be used on pod-specific labels?
Not right now, but we were thinking, it just depends on what pod-specific labels means. I would interpret it as that we have something like a filter mechanism for the profiles, to apply the profiles to a pod. Then we were considering that, but we have no real feature how we could implement it. So one idea would be to have something like mutating webhooks that we have, that we could reference Seccomp profiles in a more easy way directly from the workload, so that the operator can actually modify a pod to apply a workload automatically after recording or something like this.
Yeah, the closest you could get to that right now, I guess, is using a pod security policy that enforces using it, which isn't going to actually add it for you, right? It's just going to say like, oh, you can't create this pod without the Seccomp annotation or security context here.
Thank you for that question. If anyone else has any more questions, feel free to drop them in the chat. We will do our best to. Well, I won't, but my wonderful guests here will do their best to answer them. So I now have a Kind cluster, as if by magic.
Nice.
I have now. I don't have kubectl. I get for being too confident. See, you learn so much on this live stream, right? You learn how to install kubectl, you learn how to Seccomp stuff, you can learn how to break everything. I am just on fire. So, kubectl, try.
On Kind, it should definitely work. Because we have an end-to-end test running in Kind, which also checks for the audit log. which also uses the audit log.
Okay, we're back to where we were. So let's edit. I'm not going to have my autocomplete now. That's going to drive me crazy. Edit our config map default profiles. We're going to change this to kernel log.
Yeah.
We are going to run this pod. nginx.yaml. And we are using the default profile, which was now just modified. And kind spun up at 118, so we're still going to use an annotation instead of the security config.
Sounds good.
And won't be the same error.
Looks like you do.
Well, no, so this is a new machine. It won't have the image yet.
Oh, gotcha.
Yeah.
What's the next image? It's going to be okay. I'm so impatient. Like, nginx. Although maybe it's not going to pull the image because I would expect that to come now, which means maybe there is an error. Maybe.
Yeah, let's see.
Yeah, I'm just impatient. Code.
Oh no, that looks good. Okay, so now it's running. Nice.
So with this profile, what was failing with Docker for Mac was my ability to then exec inside of this container.
Yeah.
Which now works. But we don't care about that. What we actually want to care about is where did this log go?
Yeah. Now we have to exit the node.
So yes, that's right. We're in kind and not on the action.
Yeah.
So we can jump inside. Okay.
Yeah, now we can look into warlog audit D probably. It's not there because I think kind doesn't ship audit D.
You should be able to actually just on the machine itself, they should flow through to the syslog, right? So you could probably tail the syslog. So if you just do like tail dash, let's see. And if you could grep for test pod.
Yeah, that's it.
Nice.
That's the audit log. Yeah.
So there you get the syscall. You've got 109, 270, 111, 34, 89. So these are all ones. So since we have that allow block, that whatever block is going to take precedent of the default action, right? So these are all ones that would be blocked in Arano. So if we wanted to switch it back to Arano, we need to add all of these different syscalls there.
And you can run something like AU syscall, and then the syscall number, and then you get the name for it. Yeah.
If it exists. I actually,
I don't know what AU syscall is. What is that?
Not sure which part.
I actually haven't used it before either. Typically, I just use one of those websites, that has like the searchable thing.
It's probably part of the audit D package.
Yeah.
Yeah.
That's what I got from here. So I see, audit D there. So
nice.
Now it should be available. Yeah.
I'm learning.
Yeah, read link. Yeah.
I just pick random numbers.
Yeah.
I'm so easily impressed. Okay, that's a really cool tool. So how do I send this? Can I just send a random syscall to the kernel? Is there like a way of debugging that? No. We'll pass on that. I'll try to stop throwing like random brain thoughts actually.
Yeah.
So,
but for example, you could also do something like if you have a running or a binary application, something like strace, for example, is pretty easy to use. So if we run something like strace -c and then ls, strace is not available. Yeah.
We can fix that.
Yeah,
I know that package name.
Yes. Strace -c and then ls, for example, should give us an idea about which syscalls are now required to run this. And if we now run something like strace -cls/, then there should be, then we have a different list of syscalls because it's higher privileged. It's interesting, right? So it really depends on the application and what we want to do. Allowing something like execing into a container workload is probably good if we think about debugging an application, but we also have to reconsider then that we then allow, we have to allow additional syscalls to actually do something with the bash, for example.
Right.
So does that not make generating, I'm not going to say easy, but if I can just do strace -cls, and then assuming I just do like print 5, how does that not work? I mean, and that should work. Oh, no, wait.
Yeah, we had some discussions last week about how we could record those profiles, and the idea was, we could run something like strace, but strace has a performance implication. And if we, for example, run it without -c, then we get all the details which we don't need. So we also get all the paths for which got access during the loading of the libraries and things like that. And there is some new feature in the Linux kernel. I'm not sure if it's that new, but it's called the Seccomp notifier. And this is pretty interesting because we can create some client-server architecture in between Seccomp. So we can have something like a server, which is monitoring the actual application. And the server provides a file descriptor for a client. So which could be a different process, or in our case, probably the operator. And this operator gets then all the syscalls due to the Seccomp notifier feature. And one idea was to, how could we now bring this into the operator? And there are multiple ways. For example, there's a different container runtime like crun, which now proposed something like a plugin mechanism that we can have something like a notifier plugin to record the profiles. But all of those topics are not really standard. So we also have to say, okay, we probably can't support it on every machine because not every Linux kernel supports the Seccomp notifier, for example. There are also some ideas about to do the same like the strace thing. We could compile a little BPF module into something like an OCI hook, and this OCI hook will be triggered right before the workload starts, gets the process ID, and then starts the recording, and then puts the recorded syscalls into a predefined JSON blob. But this would also not work, for example, with containerd, because containerd does not support OCI hooks yet. Or, for example, it would also not work with Docker. So we are just evaluating, and we are thinking about possible solutions around it, but it's not that easy, right? So so the set of privileges is really high for those profiles. If we want to have something like strace, or there is also BPF trace, for example, which can where you can register tracing points for syscalls on the system, but then we would record the syscalls on the whole system and would have to look for our process, so our container process.
I guess the challenge there, though, is that in order to use strace or BPF to extract syscalls from the application, you have to run through every code path, right? Yeah. Because even just with that really trivial LS example that you showed me, the syscalls that were used between one directory and another were different. So if I were to profile or try to create a profile for nginx and someone just hadn't had a certain endpoint that uses like a redirect syntax, then you'd never know that syscall was there. Yeah. Is there not? I'm sure there isn't, or maybe there is, but I'm assuming just analyzing the ELF binary itself is the best way to get that information. Is that not possible?
Yeah, this could be possible as well. I mean, if the binary is stripped, then we don't have a chance to get the syscalls back in.
So you said that at the start of this kind of the stream, you've been working on a way to generate profiles. Is that something you want to walk us through it?
Yeah, I can show it. I can show it to you if you want. Let me just share the screen here. Well, you should see it now, right? So I just played around a bit with where is it? So I mean, I have this OCI hook installed, which is just a JSON which executes a binary right before the container workload starts. And I have to run podman as a privileged user here, because otherwise the hook wouldn't be able to export to record the syscalls. So this is a real drawback. We have to increase or decrease the security footprint by doing something like recording syscalls. So this could be a problem in the future. But what we would have to do now is just to add another annotation to the workload, which is this, in that way, IO container strace syscall. And then we can specify an output file. And for example, for other container runtimes like Cryo, it would work in the same way. We could also just add this annotation to the Kubernetes workload and then record the profile into a directory. And if we now run something like, let me just change that. We run echo hi without attaching a TTY and without doing anything in bash, then it should succeed. Yeah, this succeeds. And if we now look into the profile, then we can see that we have now a generated profile here. So it has the same default action for erroring and some syscalls in. Also, let me just save that. And now let's do something different. Now we want to attach a TTY and also run echo hi. I just override it, and then we have a look into that. Just save it as my second profile. And if we now diff those, and we can see that we have, for example, different set of syscalls here, which is pretty interesting.
Very cool. And I guess, sorry, Nico.
I mean, we could also do something that's just attached to the profile and run something like ls, or what else could we do? We could do something like rmdir and remove, or we could create a directory and we could remove it again. So this works. And if we now
you could kill -91.
Oh, we can try it afterwards. 1 second. And if we now create a third profile, it's just with our second and our third. We can see that we have many more. We have to execute bash, for example. We have to fork a process. We also have to get our current directory, for example. Otherwise, we would not be able to change into a directory. And we also should have, we have rmdir. And we also have mkdir, probably, yes.
So how did you exit that container? Control D?
Yes.
And because I don't see the exit syscall, a completely random observation, but it wasn't there.
I mean, I'm not sure if it triggers exit in the back, but let me just check. The second and the fourth probably. Okay, for bash we need all those syscalls down here, and exit. Exit is part of both, probably. No, it's not. It's exit group, but it's part of both. I'm pretty sure that if I run Control V, then it will do something like detaching from the TTI and then doing something like exit group or exit a process.
Okay, so here's a random thought. Can you just run that against nginx?
Oh yeah.
I mean, how accurate would that be to the default profile that is shipping onto Seccomp Operator?
Yeah. Do that. So nginx. Okay, it was nginx 19.
I'm curious now, right? So you, from what you've been telling me so far, this dash annotation on Podman is using something called an OCI hook. Can you explain that to me? What does the OCI hooks enable?
Yeah, so the OCI runtime specification has a direct feature baked into, which is called OCI hooks. And runtimes can support it to, for example, run a pre-start hook, which gets executed directly before the container workload starts. And this hook is just can be any binary. And then we can pass our information down to that hook, like the output path of our for our profile. But not every container runtime supports it for now, because I'm not sure. I don't think that Container T supports it. And this is going to be a problem to bring a feature via an OCI hook down to all users. Yeah, so now we have this nginx server running. I just can exit it again. And if we look at the nginx.json, then it looks like this. And we can also, I just would like to reformat it. And we can also diff this one with the one in the Seccomp operator.
I mean, what I would expect to see different here is that there's no accept call because we never browsed to it. So I guess things like that would cause the profiles to be different.
I think I have to resort this one.
Yeah, there you go. There's no accept. So
yeah,
because we never went down that code path, we never actually made a request to this area. It's a very cool tool. That's nice. I mean, that must make this so much easier for people.
I can just share it. It's this one. So this OCI Seccomp BPF hook. Has to run with a higher set of privileges. So we have to need something like capsys admin. Yeah. So this is pretty high privileged when it turns to security from the security perspective. And we also need the kernel headers on disk, which is also kind of strange, but we have to compile a BPF module on the fly right before executing the hook. And yeah, therefore we would have the need for having the actual kernel headers for the currently running kernel on disk. So
is it possible then, if say I'm using Cryo as a runtime for Kubernetes, and just to enable that tracing on all of my applications for a week, 2 weeks, and collect profiles?
Yeah, this would be possible, but I'm not sure if it's a good idea to do that in production. Right? I'm not completely sure about the security implications we introduce with that hook.
So we also have another question, which I think is touching on a few things that we've covered today. So Iger is saying it may be hard to debug a failing application with a Seccomp profile active, which I think we've kind of already confirmed because I couldn't exec into the container. What are my options for? Can I change a profile a line actively, or do I always have to restart the process to make a modification to that?
Yeah. I mean, we have to restart the process, right? And this is also some implication we had. It's about a general architecture of Kubernetes, right? If we change an annotation, then it restarts the profile. But for example, if we change the content of the profile, which is not directly referenced or which is only referenced by text, by the annotation, then it won't have any influence on the actual workload. So, yeah.
Yes.
We thought about solving this somehow, but it's probably not cool if the operator comes around and restarts your workload because just the Seccomp profile updated, something like this. Not that easy decision.
Yeah, well, that brings up another point. I mean, a big thing right now is if you actually delete a config map, then it's not going to actually get cleaned up out of the directory. So that profile still exists even if you delete it, delete the config map that led to its creation. And you may think, initially that's not a good thing, and maybe it's not. But what if you delete a config map and there's a pod using that Seccomp profile, and then later on that pod gets restarted? It's just going to fail, right? Because it's not going to be able to access that Seccomp profile. So right now we're thinking about accidentally muted there. How we want to be able to clean those up. And one way to do that is to, get a list of all the pods and say, all right, I'm going to clean this up if no pod is currently using this Seccomp profile. So that case, you don't get, where like a pod gets evicted and then can't restart. Or you could do things like, keep a global list, somehow of what pods are there. So just trying to do that without, huge performance implications. But in general, like listing pods and, getting pods with a certain annotation is not a super big deal, especially, we don't anticipate that people are going to be deleting Seccomp profiles like multiple times a second or something like that. So that's likely something we can do, but it may also be something where we want it to be configurable depending on how folks want to interact with it.
Awesome. So is there anything with the Seccomp operator that we haven't covered yet? What am I missing?
I think we've covered most of it in its current state. We have and we've mentioned a lot of ideas for the future. So if anyone's tuned in today and saying, I need this functionality, like definitely open an issue, definitely show up to our meetings. There's also the Seccomp Operator profile or channel in Kubernetes Slack. One big thing, which I don't think we touched on yet, or maybe I just forgot, is we're thinking about right now renaming this to the security operator. The reason for that being is that you can pretty easily extend this functionality to some other things. Namely, the most obvious would be AppArmor, which is kind of similar to Seccomp. And we'd like to be able to support that. And I think Sascha is actually leading the charge for making AppArmor GA as well in Kubernetes for an upcoming release, hopefully 1.20. And so as that happens, it'd be a great time to also introduce AppArmor functionality into the operator. And then there's also some other things we can do with security. So in general, Seccomp is one of the things we think is valuable and is underused because it's hard to work with. And we'd like to extend that to other things as well. So, that kind of opens up the scope of the operator quite a bit. But hopefully it becomes something that people can kind of trust on to help make using security features of Kubernetes a lot easier.
Awesome. I guess the next question after that then is, what's next for the Seccomp Operator besides the AppArmor stuff? Is there anything else coming soon?
Yeah, so we are working on the CRD, which is based on the OCI runtime specs Seccomp profile specification. So it should be give us some good opportunity to validate the content early on. And then we are working on the recording, but I'm not sure if the recording makes it into a feature anytime soon, or maybe we are trying to target another release for this year. And yeah, let's see, at least as a proof of concept, we could add it, and then we could try to get some feedback from users.
Awesome. Well, I just want to thank you both for making Seccomp understandable for me and for making it easier for everyone with your hard work. Honestly, I didn't expect Seccomp being something that I would kind of be able to get a handle on in such a short amount of time. And I think you've both done a great job of kind of walking me through this. So that's amazing.
Oh, thank you.
And that, which means you're both now committed for helping me understand SC Linux future date, because I have no idea how the hell that works either.
Yeah, well, that's another area where bringing some of that functionality into the operator would be awesome. So, but thanks for having us on. This has been super fun. And outside of this episode, I love all the stuff you're doing with the other folks you've had on as well. So appreciate you making good content to help people learn and be aware of things happening in the community.
Thank you very much. That's awesome. Feel happy now. Well, I will let you both get back to your days. If anyone has questions, you can reach out to all of us on Twitter. All of our handles are nicely on the screen. Of course, there's comments on YouTube. And thank you very much for watching, and have a nice day all.
Thank you. See you. Bye-bye.
Cheers, bye.